So assalamu alaikum guys, welcome back to my YouTube channel ChrOmaTogRaphY. I hope that you are doing good and well and enjoying your beautiful day. So today we are here with another and new interesting topic of the chromatography, which is another type of the chromatography and many important, very important and a very easy type, which is the high performance liquid chromatography. In the short form it is also called HPLC. Commonly it is called HPLC and used as the word HPLC in our daily routine life, but its abbreviation or its full form is the high performance liquid chromatography. So let's start with its introduction, that what is HPLC. It stands for the high pressure or high performance liquid chromatography, sometimes referred to as high pressure also. It is a powerful tool in the analysis. Its yield high performance and high speed compared to the traditional column chromatography because of the forcibly pumped mobile phase. HPLC is a chromatographic technique that can separate a mixture of compounds. It is used in analytical chemistry to identify, quantify, and purify the individual components of a mixture. It is a type of the liquid chromatography where the sample is forced through a column that is packed with a stationary phase composed of irregularly or spherically shaped particles, a porous monolithic layer, or a porous membrane by a liquid at a high pressure. You can see here its diagram containing different parts like reservoir tray, autosampler, column oven, degassing unit, pump unit, low pressure gradient device, system controller, and the last one is the UV detector also. What is the principle of the HPLC? The principle of separation in the normal phase mode and the reverse phase mode is adsorption, as well as the partition chromatography is depending on the nature of the stationary phase. If the stationary phase is a solid, principle is based on the adsorption chromatography, and if the stationary phase is a liquid, the principle is based on the partition chromatography. And when the mixture of the components is introduced into the HPLC column, they travel according to their high relative affinities towards the stationary phase. The component which is more affinity towards the adsorbent travels slow, while the component which is less affinity towards the stationary phase travels faster. It is important for the determination of the volatile and the non-volatile compounds and for the qualitative and quantitative analysis. Further, we have the instrumentation of the HPLC. It includes solvent, mobile phase reservoirs, degassing of the solvent, pump, pressure gauge, pre-column, sample introduction system, column, detector, recorder, and so many other things. This one is the schematic flow chart of the HPLC containing solvent reservoir, which goes into the gradient device, which is connected with the pump, and the pump the sample is converted into the simple injector through the column. Column is converted into the detector data and the recorder. Now, what are the solvent and the mobile phase reservoirs? Gas or the stainless steel containers capable of holding up to a linear mobile phase to a variety of aqueous and non-aqueous mobile phase. Degassing and the filtration mobile phase contain vacuum filtration, helium purging, ultrasonication. Now, what is pump? The solvent or the mobile phase must be passed through a column at a high pressure at up to 6000 psi or 414 bar. As the particle size of the stationary phase is smaller, the resistance to the flow solvent will be high. Now, the types of the pump used in HPLC are three types: reciprocating pump, pneumatic pump, and the syringe pump, to produce an appropriate pressure to push solvent and sample into the column. This one is the diagram containing sample HPLC pump, manner in which they operate, constant flow rate, and the constant pressure pump. Constant pressure pump pneumatic further divided into the direct pressure pump and amplifier pump, while the mechanical pump is divided into the reciprocating pump and the syringing pump. Reciprocating pump further contains single poison reciprocating, double piston reciprocating, and the reciprocating diaphragm pump. Further, we have the guard column. It is placed interior to the separating column. This protects and prolongs the life and the usefulness of the separating column. They are dependable columns designed to filter or remove particles that clog the separating column, compounds and ions that could ultimately cause baseline drift, decreased resolution, decreased sensitivity, and create false peak. Now, the sample injector system, it consists of the septum injector, stop flow injector, and the rheodyne injector. This one is the diagram of the 6-port injection valve schematic diagram. Further, we have the columns, and the columns are divided into the capillary column, fast column, analytical column, preparatory column. Further, we have the detectors, and there are the different types of the detectors, including UV visible detector, refractive index detector, photodiode array detector, fluorometric detectors, and recorder and the integrators. Types of the HPLC techniques, which are based on the modes of chromatography: normal phase mode, reverse phase mode. Second one is based on the principle of the chromatography, including adsorption, partition, ion exchange, size exclusion, affinity, chiral. Third one is based on the Lewin technique, isochromatic gradient. Fourth one is based on the scale of operation, analytical HPLC, preparative HPLC. Fifth one is based on the type of the analysis, which is the qualitative and the quantitative. And at the end, we have the applications of the HPLC. Quality control testing of drug in the qualitative quantitative analysis, therapeutic monitoring of the drug metabolism study, separation and column of impurities in the analysis of the biological fluids, stability studies, study of metabolic pathways, separation of the positional isomers, enantiomers, optical isomers, and industrial applications, including the determination of the synthetic intermediates, atenolol, and determining traces of impurities, tolnafate, and the stability studies, that is acyclovir. I hope you understand the HPLC. Go and like my video, subscribe my channel, and wait for other important topics of the chromatography. Till subscribe my channel, and Allah Hafiz.